Before this melts your screen, subscribe for more science that hits close to home. Place a sample of black asphalt, which is a common material used for roads, or even just some dark tiles on top of a light-colored tile. And then put both under a heat lamp, or if it's a sunny day, just leave them out in the sun. Measure the temperature of each tile with these infrared thermometers. You will see that the black tile heats up way faster than the white tile. In fact, the black tile gets so hot that it actually starts to melt the plastic underneath. This is why cities made out of dark materials tend to get really hot during the day. And speaking of black, if black absorbs all colors of light, what do you think white reflects? All of them. White tiles reflect most of the light that hits them, which is why they stay cool to the touch. But there is one color that white can't reflect, and that's exactly what we're going to find out in this next experiment. Have you ever wondered how planes stay so cool while flying through the hottest parts of the atmosphere? Well, it's all because of this. My dad gave me this old thermos from the 90s, when I was just a wee lad, and it's silver on the outside. It's not just for looks, though. It's because silver reflects most of the light and therefore heat that hits it. The same goes for planes. They're mostly made out of aluminum, which is right next to silver on the periodic table, and therefore has similar properties. That's why most commercial planes are painted white. It reflects the sunlight and keeps the plane cool enough for the air conditioning to do its job. But it's not just about reflecting visible light. Take a look at this crazy contraption. We've got a big chunk of ice floating in a bucket of water. And then we've got two lasers, one that shoots red light and one that shoots blue light. Now both of these lasers have the same power output, meaning they both give off the same amount of energy per second. But the red laser seems to barely affect the ice, whereas the blue laser actually makes the ice melt. Why? Well, it's because even though they look different, all light is still just light. Doesn't matter what color it is, still just waves of electromagnetic energy. Visible light is just a tiny slice of the electromagnetic spectrum. And although it may seem like a small difference, the blue light actually carries way more energy than the red light. You can also see this effect with ultraviolet light, which is invisible to us humans. If I shine my phone's flash on this piece of paper, you can't see anything. But if I put this special paper under a UV lamp, you can see that it totally changes. That's because most paper is made out of cellulose, which absorbs UV light and gives off visible light. This is why some highlighter markers only look fluorescent under UV light. They absorb the UV light and re-emit it as visible light. Now, what does this mean for our planet? Well, if ice reflects most of the sunlight that hits it, but dark materials absorb more light and therefore heat, up more, then it stands to reason that a planet covered in ice would be much cooler than a planet covered in rock. In fact, if an Earth-like planet were completely covered in ice, it could be over 35 degrees Celsius cooler. So what's the coolest place on Earth? Antarctica? Wait, no, actually that's not true. The highest recorded temperature in Antarctica was 18.3 degrees Celsius. I thought you'd never ask. It's Vostok Station, a Russian Antarctic research base. Now let's just talk about water vapor, because you know how in some cities it is really hot during the day, but then at night it is still kind of warm out. That's because cities are made out of materials that absorb and re-emit heat very efficiently. For example, concrete and asphalt tend to absorb a lot of energy from the sun during the day, and then slowly re-emit that energy at night. Water, on the other hand, has a really high heat capacity, meaning it takes a lot of energy to raise the temperature of water, and it also takes a long time for that energy to be released. That's why coastal cities tend to be a little bit cooler during the day and at night. What about places without oceans? What's the highest temperature ever recorded in Death Valley? 56.7 degrees Celsius. I'm surprised it wasn't higher considering how dark and flat it is. But what's the lowest temperature ever recorded in Death Valley? Minus 8.9 degrees Celsius. And that brings us to another amazing property of water, which is that ice is less dense than liquid water. If you take a walk down to your local ice rink, you'll notice that most of the ice is clear, which means that it reflects most of the light that hits it and therefore stays pretty cool. But as soon as it gets dirty, or there's a bunch of bubbles in it, the ice tends to turn a darker color and it melts way faster. That's because the dirt or the bubbles absorb more light and therefore more heat. Same goes for Death Valley. During the winter, it gets so cold that some of the water in the valley freezes and the ice forms a thin layer on top of the ground. Since ice is less dense than water, it floats on top and acts as a giant mirror, which reflects a lot of the sunlight back into space. So even though Death Valley is usually really hot, the ice actually helps to cool it down during the winter. But sometimes it's not ice that causes the cooling effect. Sometimes it's clouds. When clouds cover the sky, they block the sunlight and therefore keep the ground cool. If there are no clouds, then all of the sunlight hits the ground directly and heats it up. But if there are thin clouds, then they reflect some of the sunlight back into space and keep the ground cool. That's why San Francisco is known for being foggy, but it's also known for being relatively cool for such a sunny city. On average, San Francisco has about 240 cloudy days per year, so it's no surprise that the fog helps keep temperatures down. But it's not just clouds that can reflect light and keep the ground cool. Sometimes it's dust. Dust is made out of tiny solid particles suspended in a gas. And just like clouds, dust can reflect light and therefore heat. That's why deserts tend to be cooler than you might expect. The dust in the air reflects a lot of the sunlight back into space. So even though it may seem like a barren wasteland, a desert is actually quite a bit cooler than a typical forest. Speaking of forests, trees are pretty good at reflecting light. Their leaves are green, which means they absorb most of the red and blue light and reflect most of the green light. That's why forests tend to be a little bit cooler than other places. But it's not just the color of the leaves that make forests cool. It's also the fact that trees absorb carbon dioxide. Carbon dioxide is a greenhouse gas, which means it traps heat in the atmosphere. By absorbing carbon dioxide, trees help to keep the air cool. But what's the coolest place in the universe? Almost everything in space is really far away from any stars or galaxies, and therefore it's extremely cold. Scientists believe that the background radiation in space is around 2.7 Kelvin. But there are also some places in space that are super hot, like the surface of the Sun, which is about 5,500 Kelvin. The temperature difference between the hottest and coldest places in space is over 7 billion degrees Celsius. That's why it's important to remember that temperature is relative. There's no such thing as absolute temperature. We can only measure temperature differences. When I was just a wee lad, my dad would always tell me that space is so big that it's impossible to imagine. Even today, I still don't think I fully understand just how big space is. I mean, the Sun is almost 150 million kilometers away from Earth, and it's just one of billions of stars in the Milky Way galaxy. And then there are billions of other galaxies out there. Sometimes I feel so tiny and insignificant. I mean, we read just a bunch of organic molecules floating around on a tiny rock in the middle of nowhere. But then I stop and think about it. Yeah, we're probably not alone. I mean, if there are 100 billion Earth-like planets out there, then there's probably at least one other planet with some form of life on it. And if there are 100 of those planets, then there's probably at least one other planet with some form of intelligent life on it. And if there are 100 of those planets, then there's probably at least one other planet with some form of sentient life on it. And if there are 100 of those planets, then there's probably at least one other planet with some form of YouTube commenting life on it. Now, obviously, I don't actually believe any of that. There are probably no other planets with any other life forms on them. We're truly alone in this universe, but every once in a while, it's fun to pretend.